At 0:53 UTC on the 22nd of September 1979, a U.S. Vela satellite registered a sudden, and unmistakable on its instrument, double flash over a remote stretch of ocean between the Crozet and Prince Edward Islands. That two-part light signature was the very fingerprint Vela had been built to spot, historically tied to atmospheric nuclear detonations. The signal posed a stark choice. Had the world just witnessed a clandestine test, or was this an equipment glitch, misreading some natural or instrumental phenomenon? During the Cold War, Vela satellites were built to spot nuclear explosions in the atmosphere. Their main sensor, called a Bhangmeter, didn't just search for a bright flash but for a special light pattern. First a sudden intense burst of light, then a second slower glow, known as the double flash. This happened because the fireball from a nuclear blast shines brightly at first, then continues to glow as it grows and reacts with the atmosphere. Since this double flash had always shown up in past nuclear tests, seeing it on Vela instantly raised alarms. The satellite's optical trace suggested a small atmospheric event. Early estimates placed it in the low kiloton range, but the record was unusually lonely. Publicly available monitoring networks at the time did not report a clear seismic signal, hydroacoustic confirmation, or an unambiguous radionuclide plume that would normally corroborate an atmospheric nuclear detonation. The mismatch, a convincing optical cue with an absence of confirming evidence from other sensors, turned the incident from a straightforward detection into a puzzle. Scientists and intelligence analysts split over explanations. A panel convened by the U.S. Office of Science and Technology Policy, commonly referred to as the Ruina panel, judged a sensor anomaly, perhaps an instrumental glitch, a meteor-related zoo event, or an optical glint, the most likely cause. That assessment became the official public-facing conclusion. But other voices disagreed. Later, declassified files and independent re-analyses kept the debate alive. Some internal CIA documents and a few analysts argued that weak hydroacoustic signals and ionospheric disturbance reportedly seen at Arecibo, and contested reports of trace iodine, 131 in sheep thyroids in southeastern Australia, could be read as circumstantial support for a clandestine test. None of those strands provided the kind of unambiguous, reproducible proof that would settle the question, and each piece of evidence remained subject to alternative explanations. At the time, diplomats and intelligence communities quietly considered likely culprits. South Africa, then pursuing a weapons program, and Israel, long suspected of maintaining a covert capability, figured prominently in contemporaneous assessments. Both countries denied involvement, neither admitted to a test, and no state ever publicly claimed responsibility. Analysts also debated motive and opportunity, whether a regional power would risk such a test, or whether political cover and scientific ambiguity could be exploited by one state to cloak another's actions. Ultimately, attribution proved elusive. Whatever the truth of that single night, the Vela incident changed how verification was thought about. It exposed the limits of relying on a single sensor type and underscored the importance of redundant, independent monitoring. The controversy helped drive technical upgrades, more hydroacoustic stations, expanded radionuclide sampling, better satellite sensors, and fed political momentum for stronger, more sophisticated verification regimes. Elements of those improvements would later be reflected in international monitoring efforts. Established under the framework of the Comprehensive Nuclear Test Ban Treaty and the International Monitoring System, 40-plus years on, the Vela double flash remains an enduring enigma at the intersection of instrument physics, intelligence tradecraft, and geopolitics. Data can point strongly in one direction and still fall short of incontrovertible proof. Instruments can mislead, and politics can magnify uncertainty. The double flash has become more than a technical oddity. It is a cautionary emblem of how verification can fail to deliver certainty, and how difficult it can be to separate signal from ambiguity when science and statecraft collide. Enjoyed the video? Then please follow and subscribe to Mind Minute.